Gemini, Grok, Llama, GPT-5.
Well, there are multiple large language models in the world right now. Many tech giants already have their own, which includes Meta's Llama, Google's Gemini, OpenAI's GPT models, xAI's Grok models, and many more. There are also many companies who don't want to invest in creating a large language model. Rather, they are leveraging all of these large language models to create a wrapper around it and trying to make business. I'm talking about one of these latest ventures called as AI Fiesta by Dhruv Rathi. Many of you might be knowing Dhruv Rathi. Well, he recently launched his startup named AI Fiesta, where he claims that he will be providing all of these premium models at just 999 rupees. Well, I have not used it personally, but I have seen multiple users showing their disinterest or unhappiness towards this application because they faced a lot of issues while using this particular platform. They raised concern around tokens because the monthly cap was around 400,000 per month, which is itself a very less amount for an average person who is regularly using ChatGPT. Apart from that, file upload options were not available and many other issues were also reported. Well, on top of that, the ChatGPT Go news, which has recently been announced by OpenAI, has actually broken down this startup culture of creating wrapper classes around it. ChatGPT Go is now available at $399, where you can access all the top models by OpenAI. Well, why are we talking about this? Let's try to jump into today's topic, where we will be talking about large language models. And many of you might also have this question in your mind. There are so many models in the market already. Amazon has Nova, Google has Gemini, OpenAI has GPT, xAI has Grok, Meta has Llama, Alibaba has Churn. But which model to use? As a user, as an AI user, if you want to do your daily activities, to be very honest, you can actually use any of these models. But if you are a developer, you want to develop some generative AI applications or agentic AI applications, and you're confused which large language model to use as a business, this video is going to definitely help you. I will be talking about each and everything, starting from what LLMs are and what are the different LLM options available in the market. That includes open source and APIs, public APIs, private APIs, and various other options will also be discussed. By the end of this video, you will definitely have a very good understanding on which large language model to choose. If you are not a complete beginner, you already know what LLMs are, you can directly skip to chapter number 2. Well, let's get started. But before that, in case you are a complete beginner, you are confused on how to get started with your data science and AI journey, you want to learn AI from scratch, check out my Udemy link. The link will be in the description. You can check out the course, which is already a 100 hours plus program, and you can easily self-paced videos are already available. You can easily learn and become an AI engineer in the next 5 to 6 months. Any questions, reach me out in the comment section. Any other requests, if you have, let me know in the comment section, and let's jump into the video. Hi. What are large language models? So in one of our previous videos, we also talked about large language models, where we also told you that these are the various large language models that are available, and that's basically Gemini, Llama, Mistral, DeepSeek, ChatGPT, various GPT models, Nova Pro, and multiple others, right? And you can see some of them are already on the screen. Gemini is by Google, Llama is by Meta, Mistral, DeepSeek, we have ChatGPT, we have Nova Pro. Now, what are large language models? So in simple terms, it's a very simple term to understand. Combination of 3 keywords. Models. Models are pretty much something that are trained on some training data, right? And that can pretty much do something. Either they can do predictions or they can do something. So if you pass an input, it will be able to understand the context and it should be able to give you an output. That's basically a model. What is a language model? A model that is trained with lots and lots of information, right? Language data. Now let's say it could be English, Spanish, Tamil, Telugu, could be a bunch of 100 languages coming from various sources, Wikipedia, public data sets, many other proprietary data sets, newspapers, um, etc., right? So that's basically language models. And what is large language models? That means trained on tremendous data, not just gigabytes, trained on millions and millions and trillions of data. That's basically large language model, right? Now, what's the theoretical definition? Large language models are advanced AI systems designed to understand and generate human language. What are the features of large language models? The first feature is architecture. It's based on neural networks, particularly the transformer models. The training, trained on extensive data sets, learning grammar, contexts, and facts. Capabilities, text generation, creates coherent and relevant text. Context, recognitions, idioms, cultural references, and conversational skills. Okay, now many of you might be thinking, we tossed a topic called as transformers and neural networks. What does that mean? So basically, what it means is large language models are eventually nothing but neural networks. I'm not sure if you know about a neural network or not, but this is how a general neural network looks like. If there is an input, so these are two neurons, and let's say there is a middle layer and there is an output, and all of these are connected with each other. Okay, that's how a neural network looks like. So this is basically your input layer, these two are basically your hidden layers, and this is your output layer, and you provide some input and you get some output. So what I meant is large language models are eventually neural networks, but based on transformers. Now what is a transformer? So I don't want to get into the technicalities in depth, but I will try to help you out with some general understanding on transformers, right? Now transformers, it's an advanced topic, but imagine there are two parts. One is basically called as an encoder and one is basically called as a decoder. And let's say you are okay, let's say there is a transformer model. Okay, what does transformer model does? Let's say you are here and you are basically asking a question, hello, or just how are you? That's your question, and you pretty much wants to get it translated to Hindi. So your output should be आप कैसे हो? So that's pretty much what you want, right? You are passing English and you're passing to a transformer model and you're expecting the model to translate your English to Hindi. So what happens inside a transformer is, try to rub this off. So inside transformers, we basically have two parts. One is encoder and one is decoder. So when you pass this information, right? So basically you have three inputs. Let's say hello, how are you? Or how are you? Now these inputs are being, goes through multiple layers of self attention and various other things. I don't want to get into the technicalities. And then from here you are basically passing this information to the decoder understands, and they finally give you the output that आप कैसे हो. Now you must be thinking how it's able to understand that there should be 3 neurons here and 3 neurons here. That's how transformers are. They are pretty much able to understand. Now try to understand the most important thing here, which is this is pretty much your encoder. What is an encoder? That basically understands the input and encodes. So it's basically taking your how are you and it is encoding them. Now this encoded values goes to this and the decoder is decoding it and it's finally giving you an answer in Hindi. That's pretty much a transformer model, right? Now, couple of years after the transformers were created, the scientists realized that, well, transformers are generalized models which has both encoder and decoder, but they can be separated because they don't want to create a model that is generically created and does fine on multiple tasks. Rather, we can separate it out and have a different encoder model and a different decoder model that are, professional in doing particular tasks. And that is exactly where BERT was generated. BERT is nothing but a bidirectional encoder only representation of transformers. So it is only the encoder part. And after few years, the first decoder was generated, which is GPT. And whatever models that you are using right now, ChatGPT, Perplexity, Copilot, whatever it is, Grok, all of them are GPT models. They are decoder architectures. Some of you might be thinking right now that in this transformer, right, what goes into input is this part. And input is always going from the user to the encoder. But if I just have a GPT model, which is a decoder only architecture, how am I getting the input? Who is passing the input? So that's exactly what it is. The user is passing the input and the input is nothing but prompt. So for your generative AI model, which is pretty much your GPT models, which is pretty much your decoder only architectures, prompt is acting as an input. And then the generative AI model understands what it needs to do and it is providing you an output. And that's exactly what it is. Coming back to the topic of large language model, right? So large language models are of multiple types. Now we are just talking about textual part. We have Gemini by Google, Mistral, Llama, DeepSeek, multiple things. But when it comes to businesses, you must be thinking that, okay, there are so many options, right? If I start writing down the options, there is OpenAI, pretty much having different GPT versions, right? There is DeepSeek. There is Meta, which has Llama. There is Google, which is Gemini. We have Amazon, which has Nova Pro. We have Alibaba, which has Quen. What else? Are we missing on some? Yeah, we have 𝐓𝐢𝐦𝐞𝐋𝐢𝐧𝐞, Elon Musk, which is Grok 3, Grok 2, whatever it is. And let's say Anthropic, again, a very posh company when it comes to large language models, and it has a Cloud Sonnet model, right? And trust me, every week there is a new leaderboard where either of these models becomes the best model of that particular week, and that's how competitive It is right now, especially in 2025. There is no clear winner out of them. Now, if you ask me, generally speaking, yes, Cloud Sonnet is something I personally like, and I also like Grok 3. Now, I'm just talking about out of these, right? I like Grok 3 and Cloud Sonnet. But if you ask me beyond this list, yes, of course, there are some models like Mistral, which I also like. Now, the biggest question for businesses, right? Which large language to use? Because there are many. For businesses, which one do we use? Do we go for this or this or this or this? Now, this is something that we will be covering in the next video. Hi, welcome back. Let's try to talk about the large language model landscape. So in the previous video, we quickly talked about the different options that we have, right? We have GPT, we have Llama, we have Gemini from Google, Nova Pro, Quen, Grok, Cloud Sonnet, Mistral, Zephyr. Like there are hundreds and hundreds of large language models. But the question is still the same. Many of you might be thinking that nowadays there is no such specific large language model that is outperforming, right? If you monitor generative AI closely, you will potentially see some of these models to be number one in a particular week and some other model taking over that model in the next week. So today Gemini might be good, tomorrow Cloud Sonnet might be good, day after tomorrow maybe DeepSeek has overpassed Gemini, and so on. Right now in this particular world where almost all the models are very similar to each other, performing really good on various use cases, it comes down to one question from business point of view: which large language model to use? Now, which large language model to use does not only depend on cost, right? It also depends on multiple other features. So let's try to write it down. The first feature, of course, is cost. What could be rest other features? Now, cost could be your LLM cost, and there could be like a storage or a building cost, like building the model end to end, deploying it, like an end product cost, right? There could be a feature called as customization, right? Some of these models might be allowing you to do a lot of customization, and some of these models might not be providing you that. And control, as many of you might be really worried about the control part, whether we have the control over this model or not. Well, that's also a very important feature based on which we usually do the decision making. And next could be data privacy, very important point. Some of you might be creating a chatbot from a public data set. Well, in that case, you can pretty much use GPT models or OpenAI models. But when it comes to your internal documents of your company, let's say very private sensitive information, even though OpenAI enterprise version is there, which clearly says that they are having data privacy, they do not use your company specific data for their retraining purpose. But still there is a question. Many of you might be thinking whether enterprise version of OpenAI should actually be used or not. Why don't we go for an open source model, right? So data privacy also is a major concern. And community support, technical expertise, whether you have that expertise to use APIs or open source models, performance, deployment time. So a lot of features are there based on which we take a decision. Okay, so cost, total product cost, customization, control, data privacy. I will write down my sixth point as support. Okay. Seventh point could be scalability, right? And eighth point could be Technical expertise, well, I will not write. I'm assuming anybody who can deal with GPT can deal with other models as well. Lastly, it will be performance. Now, whenever I work on a particular project for a client, I usually do an analysis on all of these things. And then we give them options. We give the client multiple options that these are the different criterias, these are the pros, and these are the cons of choosing each type of large language model. Now, before we jump into like little bit more about the costing part on how each large language model costs, what are the different type of large language models that are available in the market? Let's try to talk about that. So, large language models, right? Majorly, large language models can be divided into, uh, yeah, I mean, broader wise, yes, two parts. One of them could be public APIs. Okay, let's say we will make it APIs. So large language models are available by APIs or open source. Now a question you might be asking is, what are APIs and what is open source? So APIs are basically, let's say we go to grok billing. So if you go to grok, first of all, you can easily talk to grok on grok.com. Whatever you ask, it will be able to answer. Now let's say you want to use the grok APIs in your Python code and you want to create an application like a generative AI application. In that case, you need to go to the grok's billing platform, and then you have to create API keys, right? Now grok, once you create an API key, grok will provide you an API, basically an API key based on which you can use the grok APIs, right? Now what is the drawback of this? We don't know where grok's main model sits. It could be sitting in USA, it could be sitting in UK, I don't know. I don't have a hold on where the model sits. But yes, I'm able to access the model using an API, right? So there are two major types of LLMs. One is APIs and one of them is open source. Okay. Now in APIs also, there are majorly two types. One is public APIs and one is private APIs. What are public APIs? Some of the public APIs are, I would say, OpenAI. Let's say all the GPT models, XAI, Grok. Let's say Anthropic also has Cloud Sonnet models, Cloud Sonnet 3.5, Cloud Sonnet 3.7, and so on. Right? These are all public APIs. That means you just go to their platform, individual platforms, create API keys, and you can pretty much start using them. When I talk about private APIs, they are basically APIs provided by some cloud systems that has some sort of data privacy. I mean, better than the public APIs. So let's say APIs through AWS Bedrock. Now you can also access these models using AWS Bedrock. So Cloud Sonnet 3.5 is also available, Cloud Sonnet 3.7 is also available, and various other models are also available. Llama is available, Nova Pro is available, and so on. Okay, these are private APIs. That means APIs that are provided by cloud services, right? So in this case, what's happening? Directly the companies are there, you as a user are going, creating an API key and accessing it. In private, what's happening is you as a user is going, and there is a provider called as AWS or Azure. Through Bedrock, it has multiple models, and here you are creating API keys, and then you are able to access the models. Now actually in private there is no such concept called as API key. Just for easy understanding I just wrote it down, but usually when it is through AWS Bedrock, we need to have our users created on AWS platform, and then using that users we can authenticate and start connecting to Bedrock using Boto3 libraries. Okay, and coming down to the last part, which is open source. Open source are something which are openly available, right? There are some platforms like Hugging Face or platforms like llama. Let's say I go to llama. See, DeepSeek, Llama, available inside llama. All of these are open source, but Llama 3.1 might also be available in my AWS account. Let me just open my company's AWS account. I will show you something. So let's say I'm just logging in. I will pretty much go to Bedrock, because Bedrock is the provider for AWS. And inside the Bedrock, if you go to model catalog, you will be able to see, you can see Cloud Sonnet, right? This is a very good example. Cloud Sonnet is available here. And if you also directly go to Anthropic, well, Anthropic is not available for Hong Kong users, I think. But yeah, this is not available. But on this platform, you can also create a Cloud Sonnet API key. Now, if you are directly using Cloud Sonnet, that means you are falling in this category, right? You are falling in this category. But if you are taking Anthropic through AWS, you are falling in this category. Now, many of you might be thinking, what's the difference? There is no difference with respect to performance, because eventually both of these models are same. But there is a difference in data privacy, because as you are using AWS, it's a bit more secured. Okay, so you can see here, you can see multiple models. Let's say Llama model is also available. Llama 3, Llama 3 8B, DeepSeek. So some of the models are available directly, some of the models are available through private clouds, and some of these models are open source. Now, what do you mean by open source? Open source means that I was here, right? This model, Llama, is available in Ollama, and this is an open source model. That basically means you can easily download your model to the local system and you can run these models. So Llama is also present here, is also present here. Similarly, you can see multiple other models are also available. Gemma, Quen, Llama 3.1, Mistral, multiple models are available. Okay. So now that we are clear with the different type of large language models available, many of you might be thinking that we are still not clear on which type of large language model to choose for your business, right? So selecting the appropriate large language model for your enterprise requires understanding key differences in capabilities, costs, integration requirements, and multiple things. Now on your screen what you see is a table. Well, don't go with the output price, the token price, because token prices changes every now and then. But this is like a very quick difference between ChatGPT, Gemini, Cloud, Mistral, and Llama. You can see the language model for ChatGPT is GPT 4.0. Here it is Gemini, here it is Cloud, here it is Mistral, here it is Llama. The price here is $15, $21, $75, $1, and $0.1. Of course, from cost point of view, this is a clear winner. Speed, wow, from speed point of view also, clear winner. Quality index, very low quality index, very high quality index. So you can potentially jump into the next version, like from 0.1. Yeah, this is pretty much good. uh, yeah, I would still stick to llama. Key features: generates human like response, and each model has their own benefits, pros and cons, right? So we are clear on the different type of large language models. Let's try to jump into the next topic of how can we create a tabular view and try to understand the differences between each of these options. Hi, let's jump into a quick understanding on the different large language model comparison. So first we will talk about APIs, and second we will talk about on premises, that is open source models, and then we'll try to create a deck or like a table where we can understand the differences between the open source models versus APIs. So first of all, let's try to do a comparison between the available APIs. Now, the choice of APIs is very simple. If you are doing a proof of concept and the company has no restrictions on data privacy, data privacy is not a concern. You are dealing with some information or data that the company is okay if the data goes publicly available. In that case, APIs is your blind choice, because using APIs, building your first generative AI product will be literally very easy. And when it comes to APIs, on your screen will be a comparison between different type of APIs. One of them being GPT-4o, GPT-4o Mini, Llama 3, Mistral 7B. And you can see the cost point of view. Apart from GPT-4o, rest all of them are decent, right? GPT-4o Mini and Llama 3 are doing good. Time to receive its first token, you can see time wise all of them are kind of very similar, but speed wise GPT-4o Mini is little bit better than Llama 3. So what do we choose? If I am picking this use case like a proof of concept, I'll potentially choose both of these models and try to run the use case on both of these models and compare the results, the output on based on both of these models. See, when it comes to predictive analytics, it's very simple, right? In predictive analytics, you pretty much let's say you pretty much have a data set, and then you are dividing the data set into training and test, right? And then you are potentially using the training data, doing some feature scaling, feature engineering, and then building the models, right? Model 1, model 2, and so on, model n. And then you are testing the data on multiple models, and let's say model 2 is giving you the best results, you choose the model 2 is best. But in generative AI, there is no such specific output that you can consider that this is good, right? For example, who is Roger Federer? Let's say one of the models has provided Roger Federer is a legendary Swiss tennis player, and another model has provided Roger Federer is a tennis player from Switzerland. Now, how will you identify which model has done a good job? I mean, both of these are correct answers, right? In predictive AI, it's very simple to understand, because when you are doing a classification problem and you are, let's say, classifying between category 1 or category 2, pretty much you have a concrete value, right? The first record, let's say, is category A, and the prediction can either be A or B. It's very easy to analyze and understand the performance of the models. But in generative AI, this could be difficult. But there are ways which we will be discussing probably in the advanced generative AI module on how do we actually evaluate multiple Gen AI models. Just for people who are little bit low on patience, let me just tell you that there are frameworks based on which we can evaluate the RAG models. There are also some evaluation metrics, like very traditional metrics like Blue, Rogue, Meteor, or maybe what do you call? There is something called as perplexity score or something, P score. There are multiple, and then in ragas itself there is faithfulness, there is completeness, multiple other things are there based on which we identify which generative AI models are best. But as we are discussing about the price point of view and various other features, well, yeah, if the client has no issues working with APIs, I will pick both of these as options so that I can test both of these models, evaluate and see which model is performing best. Now, if the client has an issue with privacy, then potentially I will suggest them private APIs, because private APIs are little bit safe and many companies are fine working with cloud premises. They are already on Azure or AWS, so you can pretty much pitch them those kind of APIs that are available in the cloud that they are using. For example, the company is using AWS, pitch them AWS Bedrock as a solution. Similarly, if their company is using Google, I'm not sure about Google, but I think there is something called as Vertex AI, where also they have multiple APIs in it. But anyways, so let's try to do a quick comparison between the on-premises models. Llama 2, Llama 3, Mistral Large. See, on-premises models, the only drawback is the models are physical models, right? These are open source. It needs to be in your machine, right? And even though it's free and even though APIs are chargeable, the storage cost is very high. So if you are downloading your model, let's say you are using Mistral 7B, the model itself is 26 gigabytes. So you need a storage. And let's say you are using EC2, or let's say you using a fabric capacity, you will be needing a higher capacity to store these kind of models, and you will also need GPU machines. So if you are using EC2, you can go for a GPU EC2, but it's going to be expensive. So the model point of view, the cost is inexpensive, but in order to use an on-premise model, the eventual project cost is going to go up, and that is exactly what I was talking about, right? So before we jump into this bill estimation, let's try to quickly have a difference between the APIs and open source models. So let's try to draw a simple table. Okay, now let's say I will write down features, and let's say here I will write down open source, and here I will write down public APIs. Okay, the first feature, okay, is cost. Open source models are really good because they are free, right? And public APIs, yes, they are bit chargeable. Talking about the project cost, even though open source models are free, the project cost is very high. But if you are using a public API, the project cost is very low, because you don't need a high fundu storage. Your simple 8 GB storage can also run APIs, because the major thing is calling the model, and the model does not sit on your laptop or on your server. The model is sitting somewhere else, right? Talking about control, so customization. Yeah, customization, yes, open source models are really very good with customizations because you have the model with you. And public APIs, yes, there is a good amount of customization. Maybe I'll write down 3 ticks and I'll write 1 tick here because customization is available, but limited customization. Okay. The fourth point is control. The control, yes, you have full control over the model and the data. But here you have limited control. So data privacy is a concern. Similarly, the next point will be data privacy. Data remains on your infrastructure. So definitely really good if you are using an open source model. But if you are using a public API, I won't even do a single tick because there is no data privacy. But there are some public APIs which are providing enterprise version. They claim that it's safe. So even though it's enterprise, I will still give them 1 tick. I'll not give 3 ticks. And similarly, scalability requires own infrastructure for scaling. But here for public APIs, it's scalable with providers infrastructure. So I would say yes, no problem with public APIs at all on scalability grounds. Deployment time. Deployment time, yes, little bit longer. So not good, and I will say good for public APIs. Last but not the least, we can also have performance. Well, performance depend on how costly your project cost is, how good your storage is. So I will write down 1, but here it's a really good performance. See, even though we have some clear winner, let's say for cost we have open source, free, project cost we have public APIs, customization we have this, scalability we have this, deployment we have this, and performance we have this. So it's like a 4-4 tie, but some things are very important, right? Control, data privacy are very important. And as we have a clear winner in open source for control and privacy, I usually go for open source as a solution. See, if you're looking at an end solution, open source APIs, open source models are definitely a good solution there. Public APIs will help you in quick POCs and quick prototyping, right? Now, jumping back to one of the large language model bill estimation. Well, this was one of the estimation that I did for a client who was little bit confused on what could be the potential cost. So let's say there are various aspects based on which the actual bill could differ, but assuming TTI, so TTI is the company's name, just a random name that I have taken, TTI Private Limited. Assuming TTI has 10 users accessing the chatbot, and we are training 50 documents, each 100-page long, using the LangChain index on Llama 3 APIs. Considering Llama 3 7B instruct model cost to be $0.1 per 1 million tokens, and also considering that we are doing 1000 API calls per user, what will be the estimated bill? So the token estimation is going to be assuming an A4 page with 11 point font can hold roughly 60 characters including spaces, and assuming 40 lines of text in a A4 image, the entire page might have 400 tokens per page, right? Now as we have 50 documents, the total number of tokens for 50 documents, assuming 400 tokens per page, is 50 multiplied with each PDF has 100 page and each page has 400 tokens. So it's going to be around 2 million tokens. Now let's say tokens used for 1000 API calls, assuming average of 3000 4000 tokens per API call, 10 users multiplied with 1000 API, the total is going to be 40 million. So the total tokens is going to be 42 million. The total cost, assuming that per 1 million tokens the cost is 0.1, the total cost is going to be 4.2. There is also a remarks, if we switch from llama 3 to GPT-4o mini, the same will be around $6.3. And if you switch to a GPT-4o model, which is like 10 times or 20 times more expensive than GPT-4o mini, it could be like 20 times multiplied with 6.3, somewhere around $120. And these are just API calls. Okay, this is not giving you a high level storage cost and all everything, right? We are just talking about API cost. It's a very good example that can actually help you out. Now, in case you have a similar kind of requirement in your company, then what you can do is you can also ask similar kind of questions to ChatGPT or to any kind of AI models like ChatGPT, and they will also be able to give you like a estimated value.